Scientific progress is one shining achievement of the human race. But what happens when scientists discover something that the rest of the population isn't quite ready for? The European Council for Nuclear Research, better known by their acronym CERN, has been carrying out experiments since the organization first formed in the mid-50s.
We are in a very special place here with Steve Myers.
We're standing on top of the first Hadron Collider ever built and operated.
During this time, they've come into the spotlight on numerous occasions, for good and bad. Their experiments have sparked fear of the possible creation of black holes, rips in our reality, and a plethora of other theories. Due to the size of the organization's funding and the nature of their research, one of their most famous and controversial achievements came with the construction of the Large Hadron Collider, the biggest particle accelerator in the world, spanning over 27 kilometers in circumference and cost over $4.5 billion. But many would argue that this money was well spent, as the LHC has led to some of the most groundbreaking discoveries of the past few decades, like the discovery of the Higgs boson and many other never-before-seen particles. This massive machine is capable of accelerating various particles around and around the loop until they're traveling near the speed of light and completing over 11,000 laps every second. They accomplish this with a series of incredibly powerful electromagnetics that create a magnetic field within the accelerator that's more than 1,000 times stronger than the field that surrounds the Earth. There have been some that have been wary of the effects that generating a magnetic field of this strength could have on electronics in the local area, and even its effect on the Earth's own field. Once these particles reach their top speed, 99.9999991% the speed of light, particles traveling in opposite directions are forced to collide into one another in a powerful collision in order to release massive energy and an assortment of particles. When the particle collision happens, the result is a shower of particles whizzing out in every direction, most of which only stay in existence for fractions of a second before decaying out of existence. Varying the types of particles helps researchers discover new particles in these flurries. Specially designed, super-sensitive detectors are placed around the collision sites to capture all the information from each and every collision. And this amount of information really adds up and requires a huge amount of time and manpower to sift through. Experiments at the LHC create more than 15 petabytes of raw data from these collisions every year, which then need to be meticulously combed through to sort out the data the researchers are looking for. Back in 2017, the LHC surpassed a major milestone when they had put out over 200 petabytes of data permanently into its tape libraries. To put this amount of data into perspective, 1 petabyte of data is equivalent to around 250,000 movies. But what are they looking for in all of this data anyway? They noticed something going on with a particular kind of quark. Quarks are the building blocks of all matter and come in a variety of types that physicists call flavor. Some of these flavors of quarks are incredibly unstable and will decay into other particles in the blink of an eye. The beauty quark, which has an average lifespan of 1.5 trillionths of a second, was the subject of this particular anomaly when its decay pattern was different than what scientists predicted based on the Standard Model. According to their predictions, when a beauty quark decays, it should be influenced by the weak force and transform into a set of lighter particles called leptons, either an electron or a muon, with the Standard Model predicting about a 50-50 chance for both particles. But what the data from the LHC was showing was that these quarks were decaying into muons only 70% as often as they were decaying into electrons. The only way that this discrepancy could occur is if a new type of particle that's never been seen before gets involved with this process. This has led some researchers to speculate that some new type of physics could be at play. A new force-carrying particle would mean brand new physics that could expand the Standard Model and answer a plethora of unanswered questions. Currently, our best guess on how the strange world of particles behaves comes in the theory of the Standard Model. This scientific framework describes everything we know about the building blocks of the physical world with extreme accuracy. But even with this level of accuracy, physicists know the Standard Model can currently describe only 3 of the fundamental forces: the electromagnetic force, the strong force, and the weak force. As of yet, it cannot describe the force of gravity and had no explanation for the dominant form of matter found in the universe, dark matter. During recent experiments, researchers noticed an anomaly within the data they were analyzing that fell square outside what is known within the Standard Model. And while it's not massively uncommon to find results outside this model with the sheer amount of data that the LHC puts out, something this time caught the eyes of scientists that knew that they needed to take a closer look. To try and explain this unexpected discovery, the researchers considered that there may be a new fundamental particle they called Z prime, which is, in essence, a brand new force-carrying particle. This force is more than likely extremely weak due to the fact that there have been no signs of it until now. According to the researchers, this force would interact with electrons and muons differently, but the extent of its interactions with the particles of the Standard Model remains a mystery for now. If, in fact, they did find a new force, this would be a breakthrough that physics has been waiting decades for. Physicists are hopeful that if this discovery is confirmed, it could help unlock established mysteries of the universe, like what dark matter is, or the full picture of the Higgs boson's role in creating our reality. Some are even theorizing that this unknown force may help achieve one of the biggest goals physics has had for the past century: the unification of the fundamental forces of nature. What will CERN uncover next, and what will it mean for the future of science? Thanks for watching. If you enjoyed this video, be sure to check out our other content taking a closer look at the universe and many of the mysteries it contains, like the amazing quantum discovery that may solve why we exist.